All right, welcome. This is BUS172 Information Economics, and we're going to talk about Chapter 3. But before we do that, I wanted to remind you that this week you also need to read this book, which is the variant book, The Economics of Information Technology. Okay. You need to read this because your first homework assignment is based on reading this, so make sure you put this in. Okay. The second book isn't going to be due until towards the end of the course. All right, so let's talk about Chapter 3, Information, and fortunately this textbook's not that long, so we'll get through the material fairly quickly, I believe. Okay. So Chapter 3, we talk about information and what it is. So we use it quite frequently in a variety of contexts. Okay. And so what information means can vary from field to field. We talk about it in Business 101. We talk about transforming data into information using information systems. And so as along those same lines there, I talk about in discussion 2, there's a Forbes article I'd like you to read for your second discussion, and it relates to Netflix's use of data and analytics on their data to derive value from the information that they possess. Okay, so take a look at that, and then you're welcome to start the discussion whenever you wish. Okay. All right, so we really have to think about what does information mean in the context of this course. So we start with the concept of information structure or partition, and this really helps us to compare information from different individuals. Okay. Let's just shift on. You should look at, in the first section of this reading, you should look at box 3.1, which talks a bit about the information context, the content of the universe, excuse me. And in that box, we talk about information just playing a fundamental role in science, and it comes up in, obviously, in business, the business world as well. But there's some examples there about information and the content, information content in science. Okay, so as we start off the first chapter 3 here, we talk about an example from a Dickens book about a message that's pretty garbled. Okay. And so if I were to read it, which, gosh, I would not even try to read this to you, but if you go and read it, you can probably try to figure out what's trying to be said there. Okay. All right, so we want to convey as much information as possible to recipient, but we also have limitations in how much we can transmit to an individual, the noise involved. So we have to do a trade-off between efficiency and the robustness of that information to protect against any type of transmission errors, such as there's transmission errors in the sense of computerized information. I'm not referring to that, although that is one mechanism. But if we're doing any type of information transmission, whether it's computer or otherwise, we have to be aware of things like typos and things like that. So we could look at efficiency from the perspective of what if we drop all the vowels. So the example in the book drops all the vowels in a sentence. And so this would make text very vulnerable to typos, though. Okay? I can look at that and still read that. I don't know how many of you were able to do that, but we dropped all the vowels, and I was still able to read it for the most part. But perhaps that might make it more efficient in transmission. In reality, we don't actually drop vowels in the real world, but that might be a way to increase the speed with which we can transmit information. We also talk about in this chapter around, yes, length of text can be costly, but we get a robustness from transmitting the full text, including those vowels. We're less likely to do a misinterpretation. So for me, as I stumbled through reading that text, I made a couple of mistakes. Okay? So another thing that the book talks about in this chapter is we could write text out, we could substitute a character, and we might make an assumption as to what is meant by that text when something else is meant. So the example is the word then or when is written as 7HEN. So is it intended that that should be then, or perhaps it's when? We don't really know, right? So it's good to be clear in what we're writing there. So instead of writing 7HEN, we should probably write then or when, so we don't have any misinterpretation of the information. Another example that the book gives is around phone numbers. So if we have a typo in a phone number, we may not discover it until we actually go to try to make a phone call. So we want, being accurate is pretty important for information. Messages can have meaning, so they can have concepts and convey concepts, misspoke there, but they can convey concepts that are known to the sender and possibly the recipient as well. Okay? So if the recipient and sender are both speaking the same language, then we can convey concepts that we both know that other people who might see that message may not understand. So if I say dear in writing, if it's in writing and I spell it out DEAR, that conveys a different meaning than if I do DEER. But if I say that verbally, I may not be able to deduce that unless I'm familiar with the relationship between those two parties, as well as the language. Okay? So a non-native English speaker might convey something completely different if I said dear verbally, okay, than if I did it in a written fashion. Let's see here. So economists, when they look at information, they borrow concepts from engineering and semantic approaches to information. So the economics of information were inspired by engineering, and pioneering work in the field laid the conceptual foundations for the economics of information. So one of the things that we do in when we're looking at information is we do measurements. And so we can look at early studies to determine how information was measured. And we look back in the history of measuring information, we can go all the way back to the 40s and engineering papers to conveying different ways to measure information. Okay? So the field of information economics, and we're going to talk about this in this course, but we're going to shift more to practical applications of this as we move through the course. But this is a relatively new field. Okay? So we start looking at the value and use of information in the 70s and 80s, but this has really taken off I'd say starting in the late 90s, this really became prevalent. But 2000s, 2010s, and now in the 2020s, really understanding the value of information is just becoming extremely prevalent. So the example article I had from Forbes talks about the value of looking at Netflix's data, and they have an immense amount of data. And it allows them to develop new content based on this data that they have. And so they can take this data, make it into useful information, and use that to create new content. Okay? Okay, so continuing on. So when we have asymmetric information, where we have one individual who knows more than others, then our actions may review the preferences or other private information. So if, for example, I'll use the example from the book actually. So if Fred offers his used car for $7,500, he's sending two messages. First, that he's ready to sell for that amount, and second, the car, at least to the seller, is probably worth less than $7,500. Okay. So when we buy and sell, it implies not that just we're exchanging goods, but also exchanging information. So being able to process information is going to be very key throughout this course. Okay. All right. So there's several forms of information that we'll talk about throughout this course. Knowledge is accumulated evidence or data on the world. News or message are increments to accumulated evidence. Information can be objective knowledge or subjective beliefs. We actually are seeing that a lot these days. Source of information is a message service, whereas the message is the actual message itself. So if we were to use a message service, perhaps the Weather Channel, the message is the weather forecast. Foreknowledge is information about tomorrow, and discovery is knowledge about the laws of nature or mathematics. Okay? And then fundamental information is about the states of nature, whereas meta information is about other agents' information. So hopefully as we go through the course, you'll recognize the different definitions of information and what's applicable at that particular time. Okay. All right. Information is an economic good. So I gave that example of Netflix, but data is a huge business right now. Okay, so being able to transform that data into usable information and then monetizing it is huge. We are in the information economy. A lot of businesses have created value where there previously was none, just simply by virtue of providing some sort of information. So, Netflix, Disney Plus, HBO Max, all these streaming services have monetized something for entertainment value. At its core, these forms of entertainment are just information. And so they've been able to monetize it. Likewise, newspapers, they've been able to monetize information that otherwise may not have any value. We have information services that have been monetized, things like court decisions, for example. We've got companies that monetize information from these courts. The court doesn't necessarily derive any value from their information that they present for a court case, but there are businesses like LexisNexis and Westlaw that have been able to monetize that information and use it for lawyers and other people who find value in that information are then able to use it to they're able to monetize it, sell it to these lawyers who then are able to use it to uh, result in additional court cases, which can then be monetized, the information from those as well. Okay. Information is a little different from other goods because it can be sold without being given away. It's cheap to reproduce. I think you all saw this in this particular course. It can be cheap to reproduce. And this is why information can be a little dangerous to, in terms of the value. It's easy to potentially give it away for free on accident or on purpose. So I produce a piece of information, I provide it to you, and then you go and publicize it to other people. And now you've done it for free. You've taken away the value of my information by doing that. And so we have laws in place to actually prevent that from happening, or if it happens, help make the person who created the information whole again. Information cannot be actively disposed of. It cannot be detected in a person. It's difficult to prevent it from spreading. And so actually, this is a great example of social media being used for information dissemination. Even if information is not accurate or not true, it's very difficult to prevent it from spreading. Okay? It's difficult to provide a value for information before that information is known. Okay? And so if the information that we disseminate can be based on facts, or it can just be based on other people's information, which may not be factual. And so we probably see that a lot today, especially right now. All right. So describing, comparing, and updating information. So fairly recently in 2004, there was an attempt to describe and compare information. And the assumption is that the world can take one of several states. And each state is a complete description of reality, but only one of them can be held at a time. And so a lot of times this is referred to as state space. And state space is denoted with elements. So for an example of rolling a die, or rolling a set of dice, that can lead to a various number of states. If we talk about, say, rolling dice, there are a finite number of states possible. Okay? And so when we roll the dice, there could be a finite number of possible states, and this enables us to describe information that we have. Okay? And so information structure is the result of when we split that state space up into subsets or a partition of that state space. So if we know that the state space has 6 elements of, say, a die, and if we just roll one die, there's 6 potential outcomes. We have even, we have odds. All right. So we can have signals, and signals allow us to take different values of each possible state. So that allows us to have a structure of subsets with only one element in each. So for example, the odd and even, we can have a die rolled, and that has 1, 3, and 5 on the odds, and 2, 4, and 6 on the evens. And so we can categorize those up into partitions. All right, let's move on to the next section. So we can have different types of information structures. So we can have homogeneous information, And that's an information structure where the subset doesn't overlap across individuals. Okay. We can also have heterogeneous information where subsets do overlap. And we can also have asymmetric where the information structure of a homogeneous structure might be finer than others. Okay. All right. So if we look at the example of Alice and Bob from the book, Alice knows the outcome of rolling a dice is odd or even. So she knows that it's either odd 1, 3, or 5, or even 2, 4, or 6. But Bob, on the other hand, will know only whether it's high or low. They have different information structures for each. And we can't necessarily say which one's more informative. So Bob's are 1, 2, and 3 are the low die values, and 4, 5, and 6 are the high die values. All right. Now, using the asymmetric information example, which is the next one in the book, Alice and Bob. Alice still only knows whether it's odd or even. But Bob has more information than Alice. Okay. So Bob knows everything that Alice knows about odd or even, but also whether the outcome is high or low. Okay. So, for example, if you look at the information for him with the dice, he knows that 1 and 3 are low odd, and that 2 is low even. He also knows that 5 is high odd, and that 4 and 6 can be high evens because 4 is higher than 1, 2, and 3, and 6 is higher than 1, 2, 3, 4, and 5. And then on the odd side, 5 is higher than 1, 2, 3, 4. Okay? So he knows more information. He has asymmetric information compared to Alice. Okay? All right, so then we can also have noisy information. And this is where we can have several different signals in the same state. Okay? So it can be informative, okay, where we've got things like odd and even, and we want to do a forecast. So let's say we ask an expert to do a forecast of whether we're going to get an even or an odd die value. And so we can have multiple events, and then we can have the expert make forecasts based on the values that they think are going to happen. Okay. But if they see a noisy signal, sometimes they'll forecast correctly and other times they won't. Right. Let's move on to information quality. So we can compare different information, different agents, and we can look at fineness as one criteria. So an information structure can be more informative if it has a finer segmentation. So if we look at figure 3.6 in the book, the structure on the left-hand side is less informative than the finer structure on the right-hand side. Okay. So on the left-hand side, we have 1, 2, and 4, which is 3 values. Then we have 3, 5, and 6 on the bottom portion for Alice. But Bob has 2 as a separate one, 1 and 4, and then 3, 5, and 6. So we have finer criterion to rank. Right. Let's go on to precision of signals. So if we have 2 experts, we can rank on additional criteria. So what is the precision of the signal? And so this can be equal to the probability. And if we use the dice example here with odd or even and high or low, we can end up with higher precision, which can lead to additional accuracy. We can also compare information based on the distribution of payoffs. And so that will be looked at later on in the book. All right, so going over this particular chapter, which was not a lot of pages, but it was fairly complex material. We have information as a cluster of states that we can call an information structure. That information structure or partition is a collection of non-overlapping subsets of that state space, and all of the possible states fall into one of those subsets. So the finer information structure we have for an agent, the more precisely the agent knows the true state. Okay. All right. Let's talk about the concepts that were introduced in this chapter, and then we'll wrap it up real quick. Okay. So concepts, we talked about the engineering aspect of information, we talked about semantic aspect of information, we talked about characteristics of information in the form of an economic good. We actually talked about some examples using Netflix and other types of information as an economic good. Actually, before I move on from that, I'll mention another type of usage of information as an economic good. So there are entities that do a ton of research on, say, demographics and voting patterns and various other characteristics. And they pull this information together, and then they market it as a good that they can sell to, not president, well, I guess presidential campaigns too, but I was going for more of political campaigns in general and political parties. So information on, say, voting is actually considered an economic good that is used by these parties to target. And you've probably seen examples in the news of information that may have been leaked from both sides of the political aisle in the U.S. We talked about the state space approach. We talked about information structures and partitions, and we used the examples of rolling dice and having evens and odds. We talked about events and information sets and signals, whether they're perfect or noisy. We talked about homogeneous, heterogeneous, and asymmetric information. And actually, asymmetric information is interesting because a lot of times, if we start talking about careers, which I hope to be able to talk about with you, I hope that you'll show up to an Ask Me Anything session, but asymmetric information, that's actually a really great point for your future careers. When you're interviewing, you are dealing with an asymmetric information situation. Your potential employer probably has a lot more information than you have. Now, you might have information too. So you probably have information about your skills and whatnot that maybe you're not providing perfect information to your employer. So you're dealing with asymmetric information as you attempt to value that information on both sides of that coin. So your employer trying to determine what is the value of the information that you can provide as part of your job, and you're trying to provide a value for what you think your skills are worth and the knowledge that you contain within your own brain, etc. Okay. So you're dealing with asymmetric information in that particular situation. The book talks about decision trees, Bayes rules, and a precision of signal as well. Now, I mentioned in my introductory video, we're not going to get into the math for this particular course. Okay. Not heavy. You should take a look at it in the book, but I'm not going to have you do any problems related to the math side of things. I want to talk about more practical applications of information economics in the course. So we'll go through some real examples in the course of our discussions. And your second discussion, you're going to go through and discuss the Netflix example that's provided. Okay? And so then next time, we're going to talk about the value of information. Okay? And we will go through, at the beginning of the next lecture, I will go through the case study and explain that to you.